Welcome back to the channel. This is the Earth Science Classroom. This video is on atmospheric chemistry and environmental science. And we're looking in detail at photochemical smog, the definition of this smog, what it's composed of, where it comes from, the origins, the sources of pollutants, and the effects on the environment and any humans that are exposed to photochemical smog. This is the Earth Science Classroom. What does the word mean? First, let's break down the two words. First word, photochemical. Well, the first part is photo, which derives or means sunlight, the energy from the sun, photons, and this energy is going to drive and be the catalyst for any chemical reactions that occur within the atmosphere due to the energy of the sun being able to break down and literally cut chemical bonds between air molecules and compounds to form new chemical reactions within the atmosphere. This part is the chemical part. Then we have the smog. Smog is a term where you combine both smoke and fog together, and this generally occurs in the troposphere. And the troposphere is the area of the atmosphere, or the layer of the atmosphere, where you have a temperature profile that gets colder as you increase altitude up to a point called the tropopause, which is where the temperature starts to change its trend or pattern and not get colder with altitude increase, but starts to get warmer. And that is the starting point of the next layer, the stratosphere. But the troposphere starts from the Earth's surface and goes to up and around 15 to 20 kilometers in altitude around the Earth. So it's the layer of the atmosphere right by the surface. And this is where we'll find photochemical smog. So in layman's terms, we're looking at a brown haze, a cloudy appearance, which is an air pollutant which occurs in and around the Earth's surface within the troposphere. What is an air pollutant? We've established that photochemical smog is an air pollutant. Now first, let's look at what an air pollutant is. So by definition, an air pollutant is any substance by itself or in combination with any physical, biological, chemical, or radioactive substances or matter that is emitted into the atmosphere and becomes concentrated. And that concentration of that substance, if it has an adverse effect on the ecosystem, on the environment, or on the people or humans within that area, then it becomes an air pollutant. If it's harmful to the environment, any life, it becomes an air pollutant. So air molecules can derive from both natural sources and anthropogenic sources can become an air pollutant based on the level or concentration of that substance and the effect it has on the environment. How does photochemical smog form? Many atmospheric air pollutants, including photochemical smog, start off with naturally occurring air molecules at a given concentration as per the normal atmospheric or ambient composition of our atmosphere. For example, we have nitrogen, N2, making up the majority of the atmosphere's composition chemically with around 78%. Then we have oxygen, O2, makes up around 20.8%. So the majority of the air molecules in the atmosphere are a combination of nitrogen and oxygen. And then you add in hydrogen into the mix and you get this ingredients in which can interact with the sunlight, the energy from the sun, which is derived as HV in this equation. And what you have is the sun's energy is going to basically break apart, called photodissociation or photolysis. It's going to break apart these air molecules, the N2, the O2, into different molecules and different compounds. For example, when you have sunlight hitting oxygen and nitrogen in the atmosphere and breaking them apart, you get a lot of free radicals. And two common free radicals that form from this reaction is the hydroxyl radical, OH negative, and the nitric oxide, the NO. So you're just combining different atoms and elements together to form different molecules in the atmosphere caused by the interaction with sunlight in the troposphere. And then you get these chemical reactions that form within the atmosphere naturally. So you naturally get hydroxyl radical forming with NO, which is nitric oxide, which equals NO2, which is nitrogen dioxide. And then the nitrogen dioxide is going to also form through nitric oxide plus a free radical, oxygen. And you can also get these oxygens formed through O2 interacting with sunlight and also making O3 in the troposphere, which is tropospheric ozone, which is the bad ozone, but it's at a smaller concentration. So this naturally happens, and this tropospheric ozone is then quickly broken down again by sunlight back into O2 plus the free radical oxygen or atomic oxygen. So these chemical reactions are constantly forming and breaking down in the atmosphere every second in our troposphere when exposed to sunlight during different conditions. So clear skies, warm days, and the abundance of sunlight to break down these naturally occurring air molecules in the troposphere. Now, these come from, again, natural sources like wildfires, lightning strikes from the soil given off by the ocean, microbes emitting and releasing nitrogen into the atmosphere, volcanic eruptions that happen all across the planet. This is a source of nitrogen and nitrogen dioxide. How do we go from naturally occurring ozone in the troposphere, O3, and nitrogen dioxide in the troposphere to producing or forming photochemical smog? As mentioned before, our atmosphere has a natural balance that it has attained over millions of years through natural sources of oxygen and nitrogen combining with other atoms and elements in the atmosphere to create a balance where the sunlight is producing different amounts of nitrogen dioxide and nitric acid and also ozone in the troposphere, which is a level which was manageable, a level which was natural, that was under control. However, when you add in any human activities into this formula, into the atmospheric composition, where human activities are producing vast amounts of excess nitrogen dioxide, nitric oxide, and nitrogen oxides, which is NOx, which means there's multiple oxygens in a chemical formula. When all these gases are being pumped into the atmosphere at immense levels and concentrations from human activities such as car exhaust, industrial processes, power generation, heating our homes, and this includes over 285 million cars and vehicles and trucks on the road just in the US alone, and globally you're looking at 1.4 billion vehicles pumping out extra nitrogen dioxide and nitric oxides to chemically react with sunlight and form these secondary pollutants, and one of which is photochemical smog. It's all about the chemistry. Photochemical smog really starts with the excess accumulation of nitrogen dioxide in the atmosphere from anthropogenic sources like car exhaust, and this is going to interact with sunlight and energy and break it into the free radicals and the atomic oxygen or the radical oxygen, and this will aggressively chemically react in the atmosphere with O2, which is present, 20.8%, and form tropospheric ozone, which is O3, which is the bad ozone, which traps energy and traps various pollutants and is a main constituent of smog. So the O3 can also break down when it interacts with nitric oxide and form O2 plus nitrogen dioxide. Now you add in VOCs into the chemical mix in the atmosphere, which derive from human sources just like the nitrogen dioxide, sources like car exhaust, industrial processes, heating supplies, paint, cleaning supplies, anything personal and industrial that humans interact with can cause VOCs. Basically anything that has a smell is a VOC. Now, these VOCs can break down with sunlight and chemically react with, let's say, hydrocarbon radicals and hydroxyl radicals, and this will form perioxyl radicals, which basically means lots of oxygen, and this will form NO2 when it reacts with nitric oxide. So you're looking at the constant formation of both tropospheric ozone with the excess oxygens and the excess nitrogen and nitric oxides to form nitrogen dioxide. Now, the accumulation of both nitrogen dioxide and tropospheric ozone is the main constituent or the main basis or the main components to photochemical smog. Now we add PANs into the chemistry. With the increased accumulation of both nitrogen dioxide and tropospheric ozone O3, you also have the chemical formula whereby VOCs are going to interact with hydroxyl radicals and the existing high accumulation of nitrogen dioxide and form PANs, which is C2H3NO5. So you have the carbon, the hydrogen, and nitrogen all present in this chemical formula, PANs, and it stands for peroxyl nitrate. So these are our secondary air pollutants, just like ozone, tropospheric ozone, the bad ozone, and this is the primary components to make photochemical smog because of the accumulation and excess of nitrogen dioxides and the chemical reactions in the atmosphere in certain areas of the world with highly populated, urbanized, and densely packed areas of industrial regions. And the formation of photochemical smog can be directly linked to the human activities like driving cars and industrial processes, urbanized areas, major cities, and also can be affected through other characteristics, which will be explained further. What affects or controls the formation of photochemical smog? Firstly, as discussed before, you need the chemistry, the air molecules, the certain pollutants that are going to chemically combine both primary into secondary in the atmosphere to create photochemical smog, such as O3, NOx, PANs, and VOCs. Then you need the source, the production of these ingredients in high volumes, in high concentrations, which comes from human activities. So naturally, you're going to have more photochemical smog centered around populated urbanized areas like cities and conurbations, and you need high levels of industrialization, very car-centric societies like the US, and China is also catching up quickly with the amount of cars on the road. You need the topography. The topography also can dictate and control the formation of photochemical smog. If there's a basin or depression or valley and the city or industrial area is located in that basin or depression, where you might have an increased chance of atmospheric conditions being able to promote the formation of photochemical smog and keep that smog in that area because of the depression and because of the atmospheric conditions, whereby a temperature inversion, the wind speed, atmospheric pressure being high, so it's pushing down on the area, and also cloud cover. If it's a clear sky, you have inundated sunlight in order to create the chemical reactions and photodissociation. Then you also have the season and latitude, which both play a huge role in terms of the amount of sunlight, the temperature and cloud cover, wind direction and wind speed, and generally the atmospheric pressure. So where you have a low pressure system that is persisting, where air is rising and leaving, the smog could form, but it would dissipate as it is forced up away from the surface, and it's going to dissipate up high in the atmosphere. If you have a different location with high pressure and warm climate, you're going to increase the chance of the formation and persistence of photochemical smog. And then you have the time of the day, which is linked to human activity when we drive to work, when we drive home from work, the production of industrial processes and the formation of this nitrogen dioxide in the first place. So we can see the growth or accumulation of photochemical smog as a direct relationship with when and where and how we drive our cars as a main source of this nitrogen dioxide. What is the big deal with photochemical smog? By definition, an air pollutant is something that causes harm to the environment, ecosystem, or humans, or all the above at the same time, at different rates and different effects. Now, in terms of photochemical smog, for humans that are exposed to this unfortunate air pollutant in urbanized areas with industrialization, where most of the population on this planet live in around urbanized areas like cities, you do get associated health effects from photochemical smog. Now, the acute effects is going to affect the respiratory system, with irritation and asthma symptoms being increased and perhaps even developing asthma, which leads to difficulty breathing, and you also have eye and throat issues associated with the exposure to photochemical smog. And then if, unfortunately, you are exposed to this type of smog on a long-term basis, so the chronic effects, you're looking at diseases in the lungs, bronchitis, emphysema, looking at increased chance of heart attacks and strokes, the increased chance of lung cancer, and unfortunately with women looking at pregnancy issues and issues with newborn babies exposed to this type of air pollutant. So generally, it's not advised to be exposed in a short term or long term to this type of air pollutant. And unfortunately, the characteristics of photochemical smog is it covers the entire urbanized area and can last for hours, if not days or weeks, depending on the atmospheric conditions and the amount of nitrogen dioxide and sunlight there is to produce the chemical reactions and VOCs and PANs to form the smog. And there we have all the issues, because the photochemical smog is formed through the basic processes that humans have come to rely on, like using cars, using factories, using paint and clean supplies, and adding VOCs in the atmosphere, which combine. So this is an extremely difficult subject to say, oh, we'll just turn off all of the potential sources of VOCs and nitrogen dioxide and tropospheric ozone. We'll just not have it go in the atmosphere and be a primary pollutant, and therefore we'll just turn off the sun, which then won't cause it to turn into a secondary pollutant and be so harmful. This is not going to be possible. So unfortunately, this photochemical smog is going to be a consistent air pollutant for the 21st century, and has been since the 20th century, with no realistic way to reduce this air pollutant. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.